Complex circuit. A closed circuit is composed of 100 ohm in series with a parallel combination of 200 ohms and 300 ohms resistor connected in a series of 24 volts batteries. So we have here illustrate the circuit. So we have the illustration here. So first we will fill in the data table, which is R1 is equal to 100 ohms, R2 is 200 ohms, R3 is 300 ohms. So we have also the total voltage, which is 24 volts. So take note that R1 is series, R2 is, and R3 is parallel. Okay. So next we will solve for its total resistance. So 1 over we will solve for parallel first, which is 1 over RT, or 1 over 20 plus 1 over 300. Okay, so we arrive the answer of 0.008 ohms. So that is not yet our final resistance because it is only in parallel circuit. So our total resistance for parallel is equal to 1 over 0.008 or 125 ohms. So next we will add up we will withdraw the circuit. Okay. Take note that it is 24 volts. Oops, I forgot to draw the series, which is R1 is equal to 100 ohms. And R2 and R3 is equal to 125 ohms. To find out the total resistance for this complex circuits, we will add up the R1 and R2 and 3, which is 100 plus 125 ohms is equal to 225 ohms. So that is our final total resistance. Next, we will solve for its total current. So the formula for total current is that volts over resistance, which is 24 volts over 225 ohms is equal to 0.11 ampere. So that is our total current is. Remember that in series circuit, it is this the total current is the same for it R1. So that is our current for R1. Now we will solve for the volts for R1. So volts is equal to I times R, which is 0.11 ampere times 100 ohms is equal to 11 volts. So we have now our volts for R1. Okay, take note that we will to find out the voltage for R2 and R3, we will subtract the total voltage, which and 11 volts. So 24 minus 11 is equal to 13 volts. So remember that in parallel circuit, the voltage are the same. So we will put it here 13 volts and 13 volts in R2 and R3. So yay, we have now our voltage. Next thing that we do, we will find the current for R2. Okay, so R2 is equal to 13 volts over 200 ohms is equal to, okay, let us calculate it. Okay. The answer is 0.07 amp. So that is our current for R2. R3 is the same formula. 13 volts over 300 ohms is equal to 0.04 amps. Okay, our table is almost done. Now we will solve for the power. Okay, so total power is equal to power 1 plus power 2 plus power 3. And next is substitute it. Power 1 is 1.21 watts plus power 2 0.91 watts plus power 3 0.52 watts is equal to 2.64 rather. Okay, so to find the individual power, so we will use the formula of P is equal to current times voltage. P1 is equal to 0.11 ampere times 11 volts is equal to 1.21 watts. Next, power 2. So 0.07 amps times 13 volts is equal to 0.91 watts. Okay, next, same process as power 3, which is 0.04 amps times 13 volts is equal to 0.52 watts. To make sure that our answer is correct, we will add up this 3 power. If we arrive 2.64, then our answer is correct. Okay. So that is our final answer. R1 is 1.21, R2 is 1.91. That's it. Next, we will answer the questions, the following questions. Letter C is how much power is dissipated through the 100 ohm resistor? So our answer is we will base on the table. So our answer is 1.21 watts. And letter D, how much current flows through 300 ohms resistor? So 0.04 amps hour. And what is the voltage drop? Is 13 volts. So we will draw the electron flows through the circuit. So from here to here.